Now, when we were looking at even times odd, and odd times odd a couple of videos ago, I went through proving that they were true for all possible integers. And as part of that proof, I used the idea that 2k was an even number and 2k plus 1 is an odd number. And I wanted to make that clear in this video so you can see exactly where that's coming from. So what I want to do is I first of all want to write down some integers, so in order, just so you can see where this is coming from. So we'll start with 1, then 2, 3, 4, 5, 6, 7, 8, for example. Okay? Now, what's important is that we're identifying odd, even, odd, even, odd, even, odd, even. And for those that are even, so 2, 4, 6, and 8, I'm able to write these as 2 times 1, and 2 times 2, and 2 times 3, and 2 times 4. And what's important here is that I'm able to write them as 2 times something. So every even number, as I work my way down the list, so each even number, I can write as 2 times something. So for every even number, I can write it in the form of 2 times something. So let's say k, where k is itself an integer. Remember, we're just looking at 1, 2, 3, 4. So k can take on any of those values. So 2k can be considered as a representation of an even number. Now, if you had L was an integer, then 2L is even. If you were saying N is an integer, then 2N is even. Okay, so we can write down an expression that represents an even number with whatever letter we like. If we had 3 even numbers and we wanted them all to be different, then 2k, 2l, and 2n fit the bill, okay? Where k, l, and n are integers. Now, 3 can be written as 2 times 1 plus 1. So we could write 3 as the previous term plus 1. And we could write 5 as the previous term plus 1. And we could write 7 as the previous term plus 1. So in each of those cases where 3 is odd, 5 is odd, 7 is odd, 1, of course, we could write as 0 times 1 plus 1 if we wanted to. Okay? In each of these cases, for an odd number, I can write them as 2 times k, 2 times some integer, plus 1. So 2k plus 1. And if I was working with another integer, I could have 2l plus 1 or 2n plus 1. But the very nature is that we know that that's even and that's odd. Now, we didn't have to write them that way round. Okay, so focusing on what we were looking at last time, we could write this as the next term along, take away 1. Or 3 as the next term along, take away 1. Or 5 as the next term along, take away 1. Or 7 as the next term along, take away 1. So I could write this as 2 lots of some integer, take away 1. So 2k minus 1. So we know that if 2k is even, then 2k plus 1 or 2 and 2k minus 1, I should say, are both odd. They are representing one more or one less than an even number. So you can have these different representations of even and odd numbers depending on the letters, and also in the form of odd numbers whether you've got +1 or -1. Okay? So it's really about just getting used to this language of mathematics where we are representing numbers generally.